All right, good morning or good afternoon. Here is 8.3 graphing polar equations. So let's remember when it comes to the polar system that our coordinate pair, the r is pretty much the radius, how far out you were going from the center, and theta is the initial side of that axis. Okay, so we're gonna do start with the origin and go out from there. That's what we usually do. So first thing we're going to do is graph some simple polar equations. So we either have a constant radius or a constant angle. So as you can see in A, we have a constant radius, which means if we looked at this as a coordinate pair, we would have 4 comma theta. And theta could be any angle. It's like our unknown. So with that, what we need to do is we know r, which means we're going out for the center, is 1, 2, 3, 4. Okay, I'm counting this as 1, guys, because the center is right in the middle. So 4. But if I did that every time, you would see now that I have this circle. So we actually, when the radius is a constant and theta is an unknown, we get a circle. Okay, now this goes for B too. So if we said -3 square root of 2 theta, well, that's weird, right? Because I just compared the r to a radius, and how can we have a negative radius? But if you remember correctly, a negative r just means you go backwards, right? If I start at the center, instead of going outwards, forwards, I'm going to go backwards. So every backwards and forwards, actually, since they are opposite, still contain each other. So really, if we have a constant radius, or a constant r, the radius is the absolute value. Okay, so the actual circle itself has the absolute value of r. So in this case, because I'm going to have to estimate, let me say 1, 2, 3, and the square root of 2 is going to be a little bit more than the 3. So I'm going to keep going around. Let's see. Now I'm not going to draw a perfect circle, even though I wish I could. And there we go. Okay? And of course I went too close, but I'm not a perfect circle drawer. So, okay, now let's go over, sorry for the glare, guys. Let's go over if theta was constant. So we have r, comma, 5 pi over 4. Okay, so let's remember where 5 pi over 4 is. 5 pi over 4 is down here. So remember, we're going by 15. So that would be, let's see, right here. This is our 180. So we have our 15, our 30, our 45. So it's going to be right here. Okay, so let me draw that out in green. So 5 pi over 4 is right here. And of course, every coordinate on this line has a positive r. But since r can be any number, we also have to consider that r could be negative, which means if r is negative, we are actually going to go in the opposite direction. So if theta is constant and r is our unknown, our graph is actually a straight line. Now guys, what I mean by unknown is that it could be any number. So think of it in terms of as a Cartesian point, x comma y. Saying that x is 4. Well, when x is 4, you have a vertical line. When y is 4, you have a horizontal line. It means x or y could be any number compared to that 4. So just keep that in mind. Alright, last one with the constant. So we have r, comma, negative 3 pi over 2. Okay, so negative 3 pi over 2, if we start at 0, remember negative means that we are going to go clockwise. So clockwise 3 pi over 2 would, clockwise 3 pi over 2 would be this ray right there. And again, we have the same instance that if r were negative, we would have to go backwards on this ray. So there is our line. Okay, next page. Let me adjust the camera. So now we're going to graph polar equations containing variables with both r and theta. Okay, so it's going to change. So actually, when we graph more complicated polar equations, we're actually going to create a table. Okay, now we're going to use our friendly values. We're going to use our unit circle values. You will see in some cases I will use just our 45s or pi over 4s, and in some cases I might use 30s or 60s. Really, it doesn't matter, but you want to make it more consistent for yourself, where you're not estimating all of your problems. So yes, definitely we can memorize our unit circle and memorize all of our nice friendly values, because we should be able to do it without it. So also though, make sure you have your calculator on hand to double check your work. Alright, so let's make our table. Now I'm going to say theta on this side because I'm going to plug in theta and we get r. But we know for our coordinate pair that we would graph, it is in the form of r theta. Okay, so keep that in mind. And what we're going to do is we're going to graph a whole circle, so that way our endpoints hopefully come together. So I'm going to start with 0. And if I plug 0 in, well, cosine of 0 is 1. 1 times 6 is 6. So the coordinate I am graphing is 6, 0. Okay, so I'm going to plot that now. So here is 0, and I'm going to go out 6 for the radius. 1, 2, 3, 4, 5, 6. My next one is pi over 4. Okay, well, cosine of pi over 4 is square root of 2 over 2 times 6 is 3 square root of 2. Now in this case, I'm going to be estimating, or rounding, and I put 0 instead of pi over 4. This is what I get for writing in pen. So keep in mind that the polar graphs that I'm giving you go by 15. So this is 15, this is 30, this is 45. And then I'm going to go out 3 square root of 2. So 1, I knew I did that. Hey guys, just to tell you, when I did this 6 here, I did not count this circle right here. So I'm not going to count it for the rest of this graph. So I'm going to start it to keep in mind that I did not count this circle right here. This is the center. I did not go 1, 2, 3, 4, 5, 6. See, I went out 7. So I went out 7, but I'm just going to forget this circle right here. So I'm going to start on this line. Actually, I shouldn't. Let's just unmark that. See, again, pen stink. So 45, 1, 2, 3, and a little bit more. Okay. Now, if you keep in mind, these will curve together. Okay, this will make a curve, not a line. Everything curves. Okay, because think of your circle like we had earlier. So now we're going to go pi over 2. Well, cosine pi over 2 is 0. 0 times 6 is 0. So I have 0 pi over 2. Alright, so 0 pi over 2. So right in the middle. So it goes from here to here to here. Okay. Okay. Now, next one. We're going to do 3 pi over 4. Now, when I put 3 pi over 4, I get negative square root of 2 over 2. 6 times negative square root of 2 over 2 is negative 3 square root of 2. Alright, so we get negative 3 square root of 2, comma 3 pi over 4. Alright, 3 pi over 4, let's see, this is 15, 30, 15, right here, 45 on this line, right here. But we're going a negative r, which means we're actually going the opposite direction. So 1, 2, 3, and a little bit more there. Okay, so right now I go from here to here to the middle, back around. Okay. Alright. Let's see now. Next one would be pi. So let's go to pi. Cosine of pi is negative 1. Negative 1 times 6 is negative 6. So we get negative 6 pi. Alright, so here is pi, but we're going to go negative 6. So 1, 2, 3, 4, 5, 6, and we're in the same spot. Okay, well, that's the same point as 6, 0. Does everyone see that? So this is pi, but instead of going out 6, we have to go backwards because it's negative. We end up at our same coordinate. So let's keep going and see what happens. So 5 pi over 4. Well, when I plug that in, I get negative 3 square root of 2. So my coordinate is negative 3 square root of 2. 5 pi over 4. Okay, well, let's think of that. 5 pi over 4 is down here. And if I go backwards, I'm right at this coordinate again. So as you guys can see, this keeps repeating itself over and over. And you can do that and keep going with that if you want. But once you see a bunch of them repeat, then you kind of figure, maybe I do know that it's okay. We're going to find out later that some of our repeating, we actually have to keep going. So if you wanted to, guys, just in case, you could keep going, like 3 pi over 2. 3 pi over 2, we would get 0. So we would be back at that center point. And we keep going and going and going. Now, knowing that I keep having the same pairs, you will find And of course, this is not perfect because I can't freehand a circle. And this is our graph. Okay. Alright. I'm trying to figure out if having that center and that one out there is okay or not. I'm still playing around with that. It was easier to freehand it. Okay. So as you can see in part A, there were only 4 distinct points. So we need to check with everything that we're doing if that continues. So here we have r equals 4 minus 2 sine theta. Well, again, I'm probably just going to use my pi's over 4. Yes, I know pi over 4 is going to be an estimate, but pi over 2's and all that stuff, those are going to be probably whole numbers. Okay, it's only when I have some weird mixture that I might use a different thing. I mean, we could use pi over 6's, but then we have, because we have 1/2 and that cancels out the 2. But if I do pi over 6, I want to do every pi over 6, and that seems like a lot of points. So let's see what we can do with just pi over 4. So let me start my table out. Okay, and I'm going to start with 0. So if I plug 0 in, sine of 0 is 0. 4 minus 0 is 4. So our first coordinate is at 4, comma, 0. So on my 0, I'm going to go out 4. So 1, 2, 3, 4. Okay. Now, let's do pi over 4. So this is where we get a little tricky, and this is why I like using my calculator eventually, because when I have to estimate on the graph, because 2 sine pi over 4, well, sine pi over 4 is square root of 2 over 2. So we end up with 4 minus square root of 2. So 4 minus square root of 2, comma 0. Well, of course, that's a little bit more than 2. So I'm going to go over to my pi over 4. If you guys need, start labeling it so you know where it's at. And then I know I'm going 1, 2, and a little bit more than halfway. Alright, our next coordinate is pi over 2. So sine of pi over 2 is 1. 1 times negative 2 is negative 2. 4 minus 2 is 2. So we get 2 comma pi over 2. Alright, so let's do this. So 1, 2. So if you guys see here, this is going in. It's actually decreasing, right? It's dipping inward, which if we were to graph a sine like this on a Cartesian point, remember our wave? This means probably between these points it's actually decreasing, going closer to the x-axis, or in this case we're going closer to the center. Alright, next we have 3 pi over 4. Well, sine of 3 pi over 4 is square root of 2 over 2. So we find out that this is 4 minus square root of 2 over 2. And I just noticed for that coordinate, I put 0 again instead of pi over 4. Sorry, guys. Okay, so let me make sure I'm in the right one. So this is the 3 pi over 4. Okay, and I'm going to go out again 2, 1, 2, and a little bit more than half. So I'm starting to go back out, which again, if we think of the Cartesian and we think of that wave, I bet you that's where it starts going up again. All right, we're not repeating yet, so we're going to keep going. So if I plug in pi, sine of pi is 0, so this is 4. And I get 4 comma pi. So I look at my pi and I go up 4. 1, 2, 3, 4. Next one, 5 pi over 4. So this is where it changes it up a little bit, because if we have 5 pi over 4, we get negative square root of 2 over 2. So actually, what we're getting here is 4 plus square root of 2. So I'll write down my coordinate. Now 4 plus square root of 2 is a little bit more than 5. So here we go. Let me get the 5 pi over 4. 5 pi over 4. I'm going to go out 1, 2, 3, 4, 5, and a little bit more. Okay. Let's see. Now we have 3 pi over 2. We're not repeating yet, so I'm just going to keep going with my coordinates. 3 pi over 2. Sine 3 pi over 2 is negative 1, so 4 plus 2 is 6. So 1, 2, 3, 4, 5, 6. And then next one would be 7 pi over 4. And when I plug that in, we find again we get this 4 plus square root of 2. Okay, so let's see. This is 7 pi over 4 right here. So I'm going to go out a little bit more than 5. So 1, 2, 3, 4, 5, and a little bit more. Let's do one more because we haven't repeated, and I really want to check that nothing seems funny with this, okay? So we get 2 pi, and when we get to 2 pi, we go back to 4. And what do you know? I'm at my repeating point. So now I'm going to draw this, and of course remember we're going counterclockwise, right? Because we started this way. So let me try to, it dips down a little bit and it comes back up, goes out. So as you can see with this one, it's not really a perfect circle because right here it dips down a little bit. Now, some graphs, if we spread it out, we can definitely see that dip down, and some graphs we can't. If you really want to check it out, see if you can go on a browser and look up polar graphs, and maybe you can manipulate the equation just like we do on Desmos to be able to see how these graphs change. Alright, we're going to keep going with practice here because we've got to see that there are different shapes that we can make. Okay, so with this graph here, this 2 plus 4 cosine theta, when I went over these notes, they seem to use, yep, R, and this should be, sorry guys, they actually used pi over 3, so they went by 60s. Now I want to see why they did that. Okay, so before we do the pi over 3, let's see pi over 4 and then what happens if we have to do that, okay? And I think they used pi over 3 there because of the 1/2. They wanted to see that movement in between the 45-degree angles, because this one's a little bit trickier. Not to mention that the pi over 3's, they still give us a whole number, and it's definitely easier to graph a whole number, right? So let's start with 0. If I put in 0, I get the value of 6. So 0, 6. So 1, 2, 3, 4, 5, 6. Okay. Now, like I said, they did pi over 3, but let's do pi over 4 just to check what that looks like. So if I did pi over 4, I get square root of 2 over 2 for cosine. So this would be 2 plus 2 square root of 2. And maybe this is because if we didn't have a calculator to adjust, we would have to remember that this is going to be a little bit more than, let's see, let's just do that. Oh, my battery's running out. Yay. Yeah, see, that's almost a 5. So let's actually, it's kind of crazy how that looks. So yeah, let's stick with the pi over 3. Okay, and we'll see if there's any adjustment in there of what happens, okay? So we're going to go point by point and actually look at how they're connecting, okay? So if I said pi over 3, I get 1/2. 4 times 1/2 is 2. And 2 plus 2 is 4. So we have 4 pi over 3. Okay, pi over 3 is going to be right over here. So I'm going to go up 4. So 1, 2, 3, 4. Okay, so as you can see, this pi over 4 that I'm going to skip over, it's actually already accounted for right there. Okay. So next, let's still do our pi over 3, but let's also do our knowns that we have for the 90 degrees, because those are nice numbers. So pi over 2. So cosine of pi over 2 is 0, so we get the value of 2. Now guys, remember when you do a table, you can do any thetas. Just like when we do our x and y tables, you can do any x's to produce a y. And to me, there's not really a pattern, but the more you use, the easier it is to make sure you look at the little adjustments in the graph. So 1, 2. So as you can see, this is dipping down really close. So let's keep in mind what happens here. Okay, so next I would do this 2 pi over 3 if I'm going to keep them with the 60s, right? And 2 pi over 3 would be negative 1/2. Negative 1/2 times 4 is negative 2. 2 plus 2 is 0. Okay, so this is 0. 2 pi over 3. Alright. Now, this is where I get a little skeptical, because 2 pi over 3 is right here. And then all of a sudden, I'm down here. So you need to remember that I'm not going to go straight from here to here, right? There's a roundish area in here. It keeps going out here. So since I don't want to go straight down, maybe in this case I do want to do this 45, this 3 pi over 4, because I want to see where it's coming in. Okay, so let me check. 3 pi over 4 Alright, so I would get 2 minus 2 square root of 2. And I would get this negative. It would be actually in here. So we've got to remember, guys, that this is going to curve. No lines, curve. Okay, and it looks like it's almost going to like keep going in. So let's check another point here. Let's check pi, because that would be our next one, right? But if we see pi, if we do pi in here, well, cosine of pi is -1, so that would be -2. So -2 pi. Well, if I look at pi is right here, but I have to go backwards. 1, 2. Ooh, this one's gonna look weird. So let me show you what this looks like, guys. So right here, if I were to connect these, it looks like this. But now be careful, because again, I don't want to make a straight line, but I gotta figure out where this curve ends up. So as you can see, from 0 to this 2 here, I have all these angles right here, correct, guys? So what I might do is actually look at maybe where 5 pi over 6 is, okay, like this next one right here, because I'm hoping it ends up somewhere here, so I know how to curve this. So for fun, I'm going to go back and do a 5 pi over 6. And if I find this 5 pi over 6, I would get 2 plus, no, 2 minus because it's negative, 2 minus 2 square root of 3. Now if I plug that in my calculator, just so I know, it's going to be -1.5. So I'm looking right here, guys, at this one right here, which is 5 pi over 6. But I'm going to go out to the one in a little bit more. So see, I'm right here. Does everyone see where I'm at for this? Okay, let me adjust that. Okay, I'm right here. So that helps me with that curve right here. That I'm going to this 1 and I'm going to this 2. Okay, does everyone see how that's curving? Alright, I have no points repeating, so I'm going to keep going on my graph. So I did pi, so let's do the next 60 degrees, which is 4 pi over 3. 4 pi over 3, that's -1/2. So 4 times -1/2 is -2. So we're back at 0. 0, 4 pi over 3. Okay, so what does that mean? That means at 4 pi over 3, okay, which is right down here, we are back at 0. So what's going to happen, guys, is that this is going to curve back to 0. If you want more accurate graphs in there, you can plug in these. You can plug in your 5 pi over 4 or your 7 pi over 6 to make them more accurate. Now we're starting to repeat, but that was the first one. That doesn't mean we just copy, copy, copy. So let's do 3 pi over 2 and what happens. So cosine of 3 pi over 2 is 0. So we're back at 2. So we get 2, 3 pi over 2. Now let's remember, when I look at 3 pi over 2 here, when I go a positive 2, I'm going to go in the direction of the 3 pi over 2. I'm not going to go backwards here. So 1, 2. Okay, so I'm going to connect so you can see that swirl. So I was at 0, and now I'm coming down to that 2. Okay, I'm going to keep going because, again, I want to make sure that I'm getting these points accurately. So it looks like I might finish this right over on the side here. So 5 pi over 3. Well, 5 pi over 3 is, cosine of that is 1/2. 1/2 times 4 is 2. 2 plus 2 is 4. So I get the coordinate 4, 5 pi over 3. Okay, so 5 pi over 3 is right down here. And I'm going to go towards it by 4. So 1, 2, 3, 4. Okay, that's great. Okay, so where do you think it's going to end up? Well, I'm going to think it's going to end up right back here, right? So maybe instead now we're just going to end this with 2 pi. So if I plug 2 pi in, I get my 6. And what do you know? I end up right back and I close my graph. This is a cool graph. It loops within itself. So really, guys, as you start graphing, you want to make sure that you're using enough coordinates to give that shape, right? That's like, it's cool how they can make those drawings. Who knew that math functions could make that graph? All right, let's do our next one. We got 2 more and then we are done, but we want to keep in mind what other shapes could these graphs be making if we had that weird shape right there, right? So let's see, we have our theta, our r, and our coordinate. Alright, so of course with every theta we're going to start with 0. Now because we're doubling, guys, I would make sure we are doing some easy stuff that we could do in our head if we were not able to use our calculator. And really, if it wasn't for 2020 right now, we wouldn't be able to use our calculator, so keep that in mind. So if you're watching this video for future years and it's past 2020, you're not using your calculator, so you want to use easy numbers. So let's just do our pi over 4s, or our, pi over 4s, and that will help us out a little bit, okay? So radius, if I double it of 0, so sine of 0 is 0, and 0 times 5 is 0. So we're going to start in the center. Okay, starting in that center. All right, pi over 4. Well, pi over 4 times 2 is pi over 2, and sine of pi over 2 is 1, and 1 times 5 is 5. So we're at 5 pi over 4. Alright, pi over 4 is right here. So we're going to go at 5. 1, 2, 3, 4, 5. Okay, wait a second. What does this mean from here to here? We can't just go a straight line. Now let's think about the curve. Okay, now we could do a pi over 3 and see what happens, or we could think about it. If I was going from 0 to pi over 4, that means I'm curving to pi over 4. I can't go this way because I would be hitting all the other ones, right? So I'm going this way. So double check our work here. I'm actually going to put in a pi over 6 in my calculator so I can see where that's going to end up. Okay, guys? So I'm going to go 5 sine 2 times pi over 6, and that gives us a little bit more than 4. So 1, 2, 3, 4, and a little bit more. So what this means is that we are curving here. Okay, we are curving here. Alright, let's do pi over 2. So pi over 2. So that's sine of pi. Sine of pi is 0. 0 times 5 is 0. Ooh, there's a pattern going on here, huh? So 0 pi over 2. So we're coming back down. So if you need to, then put in another value. Put in a pi over 3 if you want to see where that ends up. But what's happening, guys, is that we're curving back. Okay, now the question is, are we done? Does it keep going around and around in that spot, or does it create more? So let's figure that out now. Let's try 3 pi over 4. So that would be times 2 would be 3 pi over 2. 3 pi over 2, sine of 3 pi over 2 is -1. -1 times 5 is -5. So we get -5, 3 pi over 4. Okay, so 3 pi over 4 is right here. And if we went -5, well, that's going backwards here. So this one, right? 1, 2, 3, 4, 5. That's crazy, right? What's going to happen here? If we have to, guys, again, do your 2 pi over 3, and we'll find that it happens to be 1, 2, 3, 4, a little bit more. So it's going to come out here. Okay, now let's keep going. What happens next? Well, at 7 pi, let's see, what do we do now? Oops, forgot pi now. We're at pi. Alright, so that would be sine of 2 pi, which is 0. 0 times 5 is 0. Well, see, we're kind of repeating the same point, but we're not repeating the same circle. So it comes back to the center. Now remember, this is a sketch of the graph, guys. Don't worry about it being perfect. Okay, this is just analyzing what it looks like. Alright, so after pi is 5 pi over 4. Alright, 5 pi over 4 times 2 is 5 pi over 2, which we could actually reduce that, right? Because 5 pi over 2 is the same thing as pi over 2. So sine pi over 2 is 1, and 1 times 5 is 5. So what I meant by 5 pi over 2 is the same as pi over 2, guys, is because we keep going around and around in a circle, okay? So that means we're back up here. 5 pi over 4 is down here, right? 5 pi over 4 is right here. And remember, I'm going towards it because it's positive. So 1, 2, 3, 4, 5. Okay. If we have to figure out, okay, if I did 7 pi over 6, what would it be right here? It would be over here. So I'm curving out this way. So can you guys predict what's going to happen? So 3 pi over 2. And if we plug that in, we get 0. Okay. So it comes back around. Again, I'm not going to be too perfect here, but if you had to, do your 60s. Alright, and then after 3 pi over 2, we get 7 pi over 4, and as you predicted and you go through that, it will be -5. So our coordinates -5, 7 pi over 4. Okay, so 7 pi over 4 is right here. But I don't have to worry about this, guys, because -5 means I'm going to go away from the 7 pi over 4, which means I'm going to go back here. So I get 1, 2, 3, 4, 5. Okay, and that would come around here. Okay, I know this because I'm going from 3 pi over 2 to 7 pi over 4. So if I'm doing my coordinates within here, I would be opposite. Oh, so that actually should be on this side, right? I drew it wrong first. It would have been this side and then around. But if you can see, go back to our 2 pi and we get 0. So we are back at 0, 2 pi. And look, we just made a flower. Okay. Now we can make more petals in general. It depends on how small it's going to be. And that's why the more coordinates you use, if you are confused about which way it's going, instead start putting in coordinates. So instead of using pi over 4, do pi over 6, pi over 4, pi over 3. Do as many as you want to allow you to figure out the shape. Alright, our last one, guys, and we'll be all set for today. So, we have our r squared equals 16 cosine 2 theta. So, of course, the first thing I'm going to do is put plus or minus the square root of 16 cosine 2 theta, which of course reduces then to plus or minus 4 square root of cosine 2 theta. Now, the reason why I wanted to do that first is I want to prove to you, remember, we have some values that cannot happen. And this is why. We have a square root. So that means whatever the square root, or whatever cosine of 2 theta is, it has to be greater than 0. If the value is less than 0, it doesn't exist because we can't take the square root of a negative number. So let me get my thetas out. R and R theta. Now I'm going to go through this, but then we'll have that discussion of where that pops up. So let's start at 0. So 0 times 2 is 0. Cosine of 0 is 1. Square root of 1 is 1. So we have a plus minus 4. Okay, so we have two coordinates. Plus 4, 0, and negative 4, 0. Okay, so at 0, I have 1, 2, 3, 4. And 1, 2, 3, 4. So let's make a guess what's going to happen, guys. If this side is going to look the same as this side, right? Because we have our plus or minus. So it's kind of balanced out. Alright, let's try the next one. Let's stick with our pi's over 4s and see what happens there. So pi over 4 times 2 is pi over 2. Cosine of pi over 2 is 0. Square root of 0 is 0. 0 times 4 is 0. So at pi over 4, we're at 0. Okay, so we're back here. So we got to figure out what happened in between that, alright? So what we might want to do is we'll look at that pi over 3. So what happens? Well, if we look... Sorry guys, pi over 3 times 2 is 2 pi over 3. 2 pi over 3 for cosine is -1/2. Ooh, we can't do that, can we? I meant to do pi over 6. We'll come back to that pi over 3. I meant to do pi over 6, which is in between here. Okay, guys, it's right here. So 2 times pi over 6 would be pi over 3. Cosine of pi over 3 is 1/2. The square root of 1/2. Well, we would get plus or minus for the square root of 1/2. So I just want to see where that's going to be. So 4 square root of 1/2 is 2.8 blah blah blah. So 1, 2, so a little bit close. So as you can see, it's also negative, so I'm going to go negative here. So 1, 2, a little bit more. Alright, so what does that tell me? That tells me I start at the 4 and go inward to 0. Same thing here, but I go here and go to that -4. So this is what I've gotten so far from this graph. Okay, now let's go back to that conclusion. If we then did pi over 3, which is right here, we found that when we put pi over 3 into the cosine 2 theta, we get a -1/2. And what happens? That can never be negative. So that means pi over 3 doesn't exist. We're not going to, it's undefined. We're not going to write anything. Let's try pi over 2. Well, cosine 2 pi over 2, well, 2 pi over 2 is pi. Cosine of pi is -1. Wait, we're back to a -1. So this doesn't work either, right? Pi over 2 doesn't work. Alright, let's try 3 pi over 4. Okay, 3 pi over 4 times 2 is 3 pi over 2. Cosine of 3 pi over 2 is 0. Square root of 0 is 0. 4 times 0. Okay, so we do have a point at 0, 3 pi over 4. So at 3 pi over 4, okay, which is over here, we're back at 0. Okay, so I'm going to start there at 0. Alright, now what? Well, 3 pi over 4, now we have the next one in line would be pi. So if I plug pi in, I get 2 pi. Cosine of 2 pi is 1. So I get my plus or minus 4. Right? Well, okay, that gives us back to 4. So we go back to 4. Now, what happened between this 5 pi over 4 and this pi? Well, let's try. Did I just say 5 pi over 4? I meant 3 pi. Can't read my own handwriting, guys. So let's try what happened at 5 pi over 6, because I want to know what happens here. Something has to come back to that 0 and come back to that 4. So we're going to do the 5 pi over 6. Okay, so 5 pi over 6 times 2 is 5 pi over 3. Cosine of 5 pi over 3 is 1/2. Oh, we go back to this plus or minus 4 square root of 1/2. Okay, so remember 5 pi over 6 was right here. 5 pi over 6, if I go, and that was what? The 2 and a little bit more. So 1, 2, and a little bit more. And it also goes negative. So 1, 2, and a little bit more. And as you can see now, I can complete that knowing that I have this curve right here. okay? And remember, it's undefined right here, and it's undefined right here because cosine 2 theta would be a negative value, and we can't have a negative under a square root. Like I said, the more that you write down in your table, the easier it's going to be to graph, and then you'll be able to recognize what graphs match which functions.